Hello everyone, welcome to the remote class. So we're going to go over section 6.4, 7.1, and 7.2. Some housekeeping at the top here. We will be having a quiz on the homework from this class on the Tuesday after break. So please make sure to do that. All right, section 6.4 is about inverse trig functions and right triangles. So what is this all about? Well, sometimes you know the angle of the triangle and you want to find out what the sine is, but sometimes you know the sine and you want to find out the angle. So what I mean is, let's look at our original 6 trig ratios here. Suppose that you have a right triangle and you know what the opposite side length is, and you know what the hypotenuse side length is, and you want to work out what the angle was, so this theta that's over here. You can use the inverse trig functions to do this. And as you guys know, we have extended the meaning of sine, cosine, tangent, and the others to go beyond just what can fit in a right triangle. And so we can have angles of any size, greater than 90 degrees, greater than 360 degrees. We can even have negative angles. And when you have those kinds of angles, the meaning of sine is simply the y-coordinate on the unit circle. So you make the angle from the positive x-axis, and then the y-coordinate of the point that your angle touches on the unit circle, that is your sine, and then the x-coordinate is your cosine. And these other ones are defined similarly to how they were back in the right triangle context. So tangent is y over x, which would be opposite over adjacent. And the others are the reciprocals of sine, cosine, and tangent. Okay, so sometimes you might know, or you might have in mind, some x or y coordinate on the unit circle, and you might want to know what the angle is that gives you that x or y coordinate. So in that case, you can use inverse trig functions. So the inverse trig functions are these. This is sine inverse, this is cosine inverse, and this is tangent inverse. So the negative one there is just like the negative one that we use on f when we make an inverse function of f. It does not mean reciprocal. It does not mean 1 divided by sine. 1 divided by sine is cosecant. This is the inverse of sine. So it's an inverse in the sense that you're reversing input and output. So you're going to put in here the output from the sine function, and this is going to tell you what the input to the sine function was. In other words, the angle. Okay, so how this works is if you already know the value of sine of theta, and you don't know theta, so in other words, you know what sine of theta equals, you know x is like 0.5 or 1/3 or something, and you want to get this theta value, well, the only way to get theta out of sine is to apply sine inverse. So what you do is apply sine inverse to both sides of your equation, and then what happens here, sine inverse and sine are going to cancel out, and that's going to leave you with just theta. And then on the right-hand side, you do have to calculate whatever this is, usually with a calculator, or you might be able to do it using the unit circle. You take whatever that sine value was, and you plug it into the sine inverse function. And the other ones work the same way. Okay, so if you knew what cosine theta was, and you wanted to find theta, just apply cosine inverse to both sides of the equation. In other words, plug both sides into the cosine inverse function. You're going to wrap cosine inverse around the left side of the function, just like wrapping a glove around your hand. And you're going to wrap it around the right-hand side of the function as well. On the left-hand side, the cosine inverse and the cosine are going to cancel out. That's going to leave you with just theta. And then on the right, you have to calculate whatever this is using a calculator or the unit circle. Okay, and the last one works the same way. All right, but there's a really big important warning here. You might remember that when we studied inverse functions, we first had to learn about the concept of one-to-one. So a one-to-one function is when each output, each y value has only one corresponding x value. And you can test this using a horizontal line test on the graph of the function. So I'll explain this more in a second, but basically sine, cosine, and tangent, sine and cosine look like waves, and tangent, it's not exactly a wave, but it is a repeating function. So none of these three is one-to-one. They all super duper fail the one-to-one horizontal line test. So they cannot be fully inverted. However, you might remember that back when we talked about inverting functions, I mentioned that you can always invert a piece of a function. If you just isolate one piece of a function that is one-to-one or that does pass the horizontal line test and kind of like delete the rest of the graph, you can always invert a little piece like that. And so that's exactly what we do with these inverse trig functions. So let me explain in more detail using sine. So let's say you know that sine of theta for your theta value that you're interested in is square root of 2 over 2. And you want to know what could theta have been. Well, there are actually infinitely many different theta values that all have sine of theta equaling square root of 2 over 2. So the two most obvious ones are looking at the unit circle, square root of 2 over 2, that is the x and y value for the 45-degree angle, which is the same as pi fourths. So remember the top half of the circle is pi, and this is a quarter of pi. Okay, so this is pi fourths. But over here as well, 3 pi fourths, that also has the same y value. See, these are the same height. So both of these angles, pi fourths and 3 pi fourths, have sine equal to square root of 2 over 2. But it's not just those ones, because you can go all the way around the circle and come back, just add 2 pi. Those ones also have sine equaling square root of 2 over 2, and you can just keep going, circle around as many times as you want. And in fact, we could even circle around backwards and get negative angles. Okay, and now looking at the graph of the sine function, if you think about putting a horizontal line right at the height of square root of 2 over 2, that tells you where are all the points that have the y value of square root of 2 over 2. And then you can check what were the input values, the thetas, that would give you those y values. And it's just these same ones up here that I've listed out. So this super duper fails the horizontal line test. Okay, so the upshot of all this is whenever you want to ask this question, I have a value for sine, what was my theta? The answer is always that there are infinitely many different thetas that it could have been. But these inverse trig functions are only going to give you one of them. So the inverse trig functions, they are functions, which means they can only give you one number as an output. So somebody way back when they first invented all this just had to sit down and decide, okay, which one are we going to call the most important one that is going to be the answer from this sine inverse function. And as you might guess, it's like the angle that's in quadrant 1, or if the answer is not in quadrant 1, then like close to quadrant 1. So here's how it works out. So if you plug into sine inverse with your sine value, sine inverse is going to give you an angle that is between negative pi halves and pi halves. So looking at the unit circle, pi halves is up here, that's 90 degrees. Negative pi halves is down here, that's negative 90 degrees. So sine inverse is going to give you an angle in one of these two quadrants, quadrant 1 or quadrant 4. And if you look at the graph of the sine function, I've highlighted the region there where the inputs are between negative pi halves and pi halves. And you guys can see that this little piece of the sine function does pass the horizontal line test. So that is the portion that was chosen to be inverted. Now looking at cosine inverse, you guys can see by yourselves from the graph that it was not possible to choose the same interval from negative pi halves to pi halves for inversion, because that would already fail the horizontal line test. It would be this top half of a wave right here. So they had to pick a different portion. And so whoever it was that first decided picked the region from 0 to pi. So what that means is if you have a cosine value and you plug it into cosine inverse to find out what angle it came from, you're going to get an answer between 0 and pi. So that is the top half of the unit circle, quadrants 1 and 2. Okay. And then lastly, for tangent inverse, they were able to pick the same interval as for sine. We never looked at the tangent graph, but this is what it looks like. It has vertical asymptotes everywhere where the slope, remember tangent is slope, so everywhere the slope would be undefined, when the angle stands upright at 90 degrees or negative 90 degrees. Anyway, they pick the same interval from negative pi halves to pi halves. So if you have in mind some tangent value and you want to figure out what angle it came from, you plug your tangent value into tangent inverse, and it's going to give you an answer of an angle in quadrant 1 and quadrant 4. Okay, but keep in mind, there were really infinitely many answers to the original question of what angle did my trig function value come from. Sine inverse, cosine inverse, and tangent inverse can only give you one answer. So it's up to you as a human to be more intelligent than your calculator and to know if you had some extra information about that angle, like if you knew that it was in a certain quadrant, then you have to use that yourself to work out what the original angle actually was. Okay, I know all that was probably fairly confusing. Let us go ahead and look at some examples. Oh, one last thing first. This is just summarizing some of the same information that I just went over. And then the little extra part here at the end, the sine inverse, cosine inverse, and tangent inverse functions are sometimes called arcsine, arccos, and arctan. Personally, I like calling them that because it avoids that thing of students thinking the -1 exponent means the reciprocal. So I often call them arcsine, arccosine, and arctangent. Again, the names are just very mysterious. I don't know who decided these. Okay, let's look at some examples here. So example number 1, we want to find the exact value of 3 inverse trig functions here. So part A, I'm doing sine inverse of square root of 3 over 2. So for part A here, basically I'm asking what angle would have a sine value of square root of 3 over 2. Okay, so that's what I'm trying to figure out, which angle gives me that sine. And so I'm just going to look on the unit circle. Okay, so I just paused the video and went and found a picture of the unit circle. This is only quadrant 1, but that's really all I need because I can get the rest of it by symmetry. Okay, so I'm asking myself what angle has a sine value of square root of 3 over 2. So that's the y value because it's sine. And I'm looking at this y value right here, square root of 3 over 2. And that is coming from the angle of pi thirds. And so the answer is pi thirds. And that means that sine inverse of, I'm going to put mine in parentheses, square root of 3 over 2 equals pi over 3. By the way, if they don't tell you what form to put your angle in, like radians or degrees, in math you should assume that they probably want radians because that's a more natural angle measurement. Okay, let's do the next one. So part B. Part B, cosine inverse of -1/2. That is asking me what angle has a cosine of, not a consine, a cosine of -1/2. And so I'm going to answer that with my unit circle. So I see in quadrant 1 here that the angle of pi thirds has +1/2 for the x-coordinate. So that would be cosine inverse of +1/2. So if I flip this point right here over into quadrant 2, I should get the angle that has -1/2 for the cosine. So flipping over to here is going to be 2 pi thirds. Right. So the answer to this one is, oh, and by the way, I should mention something, but let me type this answer in first. So cosine inverse of -1/2 is 2 pi thirds. I should have mentioned actually that, there's infinitely many different angles that could give us this sine and also that could give us this cosine. I'm just going to the ones that are in the right quadrants for how we talked about the parts of the function that were inverted up here and like what range the answers can come out in. Okay, so sine inverse is in angles in quadrants 1 and 4. Cosine inverse is in quadrants 1 and 2. Okay. And let's see, the last one here, let's see. So this is asking us what angle has a tangent of 1. Remember that tangent is y over x, so it is actually the slope of the little, what should it be called? The little segment that comes from the origin and touches the unit circle. Slope, angle, segment. Gosh, I can't spell today. So a slope of 1 means it's going to be like at a 45-degree angle like this. Okay, so that is going to be pi fourths. And if you guys look at the sine and cosine values here, you can see sine over cosine here are the same. So when I divide sine over cosine, I'm going to get 1. Okay, so this answer, tangent inverse of 1 is pi over 4. Okay. Right. For the next example, we're going to do some approximation. So that means to use a calculator. So give me a second to get my calculator open. Okay, so here's my calculator. And as you guys can see, this is in degrees. See the little deg sign here? Now the example doesn't tell me what form to put my answer in, but I'm going to default to radians when I don't know. So let me find the right mode here. I think it's this button mode. And then, yeah, I'm going to use my arrow key to go to rad and then hit enter. There's also a thing called grad, which I have never used in my whole life. So, all right, and now I'm going to go, let's see, what do I do here? Clear? Yeah, so now you can see rad means I'm in radians. So for sine inverse, it's the green text above the sine key. So I'm going to do second sine, that does sine inverse, and then I'm just going to type in this number, close parentheses, hit enter. Okay, so my answer here for part A is 0.789, and this is radians. I usually don't write radians as a unit because technically it's a unitless measurement, but I'll just put it on the first one there to be clear. All right, the next one is tangent inverse, so second tan, and I'm going to put 2. Okay, so 1.107, and then the last one, oh, I already know something is funny about this last one. Let's see if you guys can see it. Cosine inverse of 2. What's wrong with this? Yeah, this last one is impossible. Okay, so why is this impossible? Because there's no angle that has a cosine of 2. Right, cosines are the x values on the unit circle. Unit circle has a radius of 1. There's no x value on the unit circle that is equal to 2. This whole dang circle, like, just only goes out to 1. 2 is over here somewhere. Okay, let's look at example 3 here. So now we actually have a right triangle, and we want to find the angle in it. So looking at the 2 side links that I have here, this 10 is opposite the angle, and 50 is the hypotenuse. So opposite and hypotenuse. Remember back to your little mnemonic, so ka, toa. We have the opposite and the hypotenuse, so we want the sine. So this triangle has sine of theta equals opposite over hypotenuse, 10 over 50. And now I'm trying to find theta. So what I need to do is get theta out of this sine function right here. Then I need to take sine inverse of 10 over 50, which is the same as 1/5. Okay, so I'm going to do sine inverse of both sides. Okay, and then on the left-hand side, the sine inverse and the sine are going to cancel out. Just give me theta. And on the right, I have sine inverse of 1/5. You can skip directly from this first step down to this third step here if you want to. I personally like to go through the middle step. I think I just feel more comfortable, but it's up to you. Okay, so now what am I going to do with this? I don't know, on the unit circle, there's no y value of 1/5 for these common angles. So I kind of just have to resort to my calculator to figure this out. So I'm going to do second sine 1 divided by 5, and I'm getting 0.20 or 0.201, I think. Yeah, 0.201. So theta, oh, I should have used these little approximate symbols. Oops, on these ones up here, I guess. Okay, if you guys remember, 1 radian is about 1/3 of the top half of the circle, so about pi-thirds. And this is about 1/5 of that, so it should be a very small angle, and this does look quite small. So this answer doesn't seem like there's anything wrong with it. Nothing fishy. Okay, let's do the next one. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? Okay, so this is another one just like this one. In fact, yeah, it's the same trig ratio. It's sine again, because we have the opposite side and the hypotenuse, but this one is just applied. So we have sine theta equals 6 divided by 40, so opposite over hypotenuse. And so that means that theta is going to be sine inverse of 6 over 40. So I've skipped over the middle step where I plug both sides into sine inverse. And for this one, I would say you probably, it doesn't say what form to put the angle in, but if this is an answer that I'm going to give to a guy who's going up on a ladder, like I'm sure he probably wants it in degrees, right? Because if you have like a protractor or something and you're trying to achieve some particular angle, and you're using feet to measure your lengths, then you almost certainly are using degrees for your angles. So I'm going to do this one in degrees. So I'll go back to degree mode here, enter, okay, clear. All right, so second sine 6 divided by 40, hit enter, and okay, about 8 or 9 degrees. Yeah, I mean, that's a pretty tall ladder, so pretty small angle. I think it's even smaller than the picture is showing, actually. So 8.627. And that is, oops. So I was trying to do some keyboard shortcuts to put the degree symbol in there. Okay, that is degrees. All right, so this concludes the material for section 6.4, but I want to give you one last warning before I stop the video and then direct you to the 7.1 video. So the warning is there is no way to get anything out of a sine, cosine, or tangent except by using these inverse trig functions. So when you see something like this, sine of theta equals 6 over 40, you just think of that sign as like a locked box that you cannot open. It is a padlocked box. You cannot get that theta out of there except by using the key of the sine inverse function. There is no other way. So in particular, usually whenever I teach trig stuff, I see some students try to do some really nonsensical moves, such as this. So a thing I've seen students do before is they have one sign on the top of a fraction, another sign on the bottom of the fraction, and they go, oh, I know, I'm supposed to cancel things that are the same on the top and the bottom. I'm just going to cancel these signs, and then I just have 2 theta over theta. Oh my gosh, guys, do not let me catch you trying to do this. This is absolute nonsense. Sine is not a variable that can be canceled out. If this was like x over x, then yeah, you can do it. But sine is not a variable. Sine is the name of a function. You cannot cancel names of functions. So please don't let me see this. I will be very, very sad. Okay. All right. So that concludes the 6.4 video, and next is the 7.1 video.